Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad HIDAYAT bin NAZRI. My metric number is 211293344. Today I want to demonstrate Lab 5 subject control system technology, which is effect of different PID value. In this lab, I construct this simulation using MATLAB. This is a without using PID, and then this is a coding for MATLAB. For numerator and denominator, just straightforward get from the question. And I using the system, declare the system. And when I run this simulation, I get this graph. And then we need to show all the characteristic, which is peak response, settling time, rise time, and the last is a steady state. Steady state is not appear because the steady state is a zero or don't have steady state for this graph. This is all parameter I get from the simulation for the response TF without PID controller, and the I get from the rise time is 2.59. For the settling time is 4.6, and the final value is 0.5. This value I put at the table in this table, and next I will run for the which PID controller when KP is increased while KI and KD is constant. Based on the question, I run this simulation using MATLAB, and then we can see I use for the we declare two system in this simulation, which is system PID1 and system PID2. We can see the KP is increased from 10 to 15 when I run this simulation. And then we can see I use three color for the system, which is for system is red, system PID1 is a yellow, and system PID2 is green. For this result of simulation, I show the parameter of the output, which is peak response, settling time, rush time, and steady state. This is all parameter I get from response to TF when KP increase while KI and KD is constant. Next, I will run simulation for when KI is increased while KP and KD is constant. I will run in MATLAB. This is a coding for the class. When I run the simulation, same. I show the all parameter. The result PID is same, and then the increase is at system PID1 and system PID2. The final steady state we can see is at 1. The output is moved to the 1. This is all parameter I get from this simulation, and from this coding we can oh, in this table we need to fill in this table. We can get the transfer function from command window. We can see this is for system 1 and this is for system 2. For the second simulation is when KD is increased while KP and KI is constant. I will run this simulation. First, and let's say statistic. We can see all parameter and final value is a 1. Final value for ni is a constant and same from previous simulation. The change adds the rest time and overshoot. This is when respond to a TF when KD increase while KP and KI is constant. Next, all parameter I fill in this table. For the task 4, I perform the calculation to get the transfer function and I will run this using MATLAB. This is a coding for the task 4.1. When I run this simulation, I get this graph and I show the all parameter characteristic, which is speed response, settling time, rest time, and steady state. This is a response TF without PID controller. And then next is a which PID controller. Transfer function P controller is a KP 300, KI is 0, and KD is 0. This is a coding for the which PID controller, and I will run this simulation. This is a response I get from which PID controller when KP is 300, KI and KD is 0. We can see all parameter. For example, the overshoot is 40.1 at time 0.184. This system is rush time is 0.0727. Settling time is 0.772 and final value is 0.938. Next, I will run for the when transfer function. PI controller is 300, KI is 10, and KD is 0. We can see this graph. This is all parameter I get when the respond to a TF when KP is 300, KI is 10, and KD is 0. Next, I will demonstrate when KP is 350, KI is 0, and KD is 50. This is graph I get from this simulation. This is all parameter I get. And for the last simulation is when KP is 350, KI is 300, and KD is 50. This is last coding I use. All parameter we need to adjust here. And this is for system 1. We need to fill in table for the transfer function we get from here. from when we see the system PID1. So I run this simulation. This is a final graph I get when KP is 350, KI is 300, and KD is 50. So I show all characteristics from this simulation. From this graph, we can see the system PID1, the final value is 1. For the settling time is 0.831 and rise time is 0.0548. For the without PID controller, the system is 0.833. For settling time is 1.49 and the final value only 0.0476. So my conclusion, we need to use PID controller to much better this system. That's all from me. Thank you.